This is the Progress Check 2 homework video. It goes along with handout 8. Learning targets that are addressed in this homework assignment are to identify the key characteristics of quadratic graphs from standard factored and vertex form, sketch accurate labeled graphs of quadratic equations, and write a quadratic rule to match a given graph. We've got some general patterns that I mentioned in a previous video that are good to keep track of, especially as you're getting to the point where you're going to be memorizing these patterns. And we're going to use these main ideas as we approach finding each piece of information from each form that we look at in this video. So our first example, we're going to look at all three forms at the same time, standard, vertex, and factored, and we're going to find each key characteristic for each of the forms. So we're going to start by finding the x-intercepts, and the main idea behind finding the x-intercepts is that we have to set the equation equal to 0 and then solve for x. So we'll start with standard form, set the equation equal to 0, and when we solve equations in standard form, quadratic equations that are equal to 0, we use quadratic formula for that. You can also try factoring, you can also try rewriting it into vertex form, but if neither one of those things work, then quadratic formula will always get your solutions. So we'll identify our a, b, and c values, and then plug those into the quadratic formula. And then we'll simplify all parts of the quadratic formula to get the final answers of -4 and +6. Since these are x-intercepts, we need to make sure to write those as ordered pairs. Now we'll take a look at finding x-intercepts with vertex form. Again, we set the rule equal to 0. This time we don't need to use quadratic formula or anything. The x only shows up in one part of the rule. So we can just cancel everything that's around that x by doing the opposite of what we see. We can start by subtracting 50 from both sides. Then we would divide both sides by -2. Take the square root of both sides. And anytime you take the square root, you have to remember to put plus or minus in front of your answer for that. And then the final step would be to add 1 to both sides. So that gives us our solutions of +6 and -4. Again, we need to make sure to show those as ordered pairs. As we're working through this, the examples that I chose, standard factored and vertex form, all represent the same equation. So we should be finding the same information from each form. Last, we'll look at factored form. Again, we'll set the rule equal to 0. And when you're solving an equation written in factored form, we want to use the zero product property, which says that anytime that you multiply things together and get 0 as a result, one of those things has to be 0. So we've got two options for that. We've got two factors that have an x in them, x plus 4 and x minus 6. So one of those things has to equal 0 if we're going to end up with an overall result of 0. With the first equation, we'd subtract 4 from both sides. The other one, we would add 6 to both sides. And so that's where our two separate answers come from, -4 and +6. Again, we need to show those as ordered pairs. Now we'll take a look at finding the y-intercept. Main idea behind finding the y-intercept is to plug in 0 for x and solve for y. So we'll start with standard form, and I'll rewrite the equation but replace all the x's with zeros. And then I'll simplify that and end up with a final result of 48. Y-intercept is an ordered pair, so I need to make sure and express that as an ordered pair. X value being 0, y value being 48. Anytime that you're looking at standard form, it really just makes sense that the y-intercept is the constant value at the end. Plugging in 0 for x gets rid of the terms that have x's attached to them. Now let's take a look at vertex form. Rewrite the rule, but replace the x with 0. And then we'll simplify from there. So that gives us a value of 48. And again, we want to make sure to write our y-intercept as an ordered pair. Last, we'll look at factored form. Again, we'll write the rule, but replace the x's with zeros. And then we'll simplify what we see. And again, we get the value of y equals 48. Next, we'll take a look at the line of symmetry. With the line of symmetry, there are special shortcuts with each different form that will help you identify that value quickly. With standard form, you want to use opposite of b over 2a. Vertex form, it's the opposite of the number in the parentheses. And with factored form, the line of symmetry is halfway between the x-intercepts. And finding the x-intercepts with factored form is typically pretty simple. But of course, if those shortcuts are hard to keep track of, or if you're taking a quiz or test and you forget them, then you can always just stick with the last main idea, which is that the line of symmetry is always halfway between the x-intercepts. So that can work for all three forms if you forget the other shortcuts. I'm going to go ahead and use the shortcuts though. So for standard form, line of symmetry comes from the first part of the quadratic formula, opposite of b over 2a. My b value is 4, my a value is negative 2. So the opposite of my b value would be negative 4. In my denominator, I would have 2a, which would be 2 times negative 2. And I simplify that fraction and get 1 as my result. Now the line of symmetry is not a specific point on the graph, but it's a line that cuts the parabola in half. So this one we will not show as an ordered pair, we'll show it as an equation, x equals 1. Now we'll take a look at vertex form. Line of symmetry comes from the opposite of the number inside the parentheses. So x equals positive 1. No calculations needed on this one. And then from factored form, we said that the line of symmetry is between the x-intercepts, so we can start by identifying the x-intercepts, which would be negative 4 and positive 6. We get those values from looking at what makes each factor equal 0. Then we figure out what number is halfway between those two values. So we'll add them together and divide by 2, and that gives us our line of symmetry of positive 1. Next we'll look at finding the vertex. Main idea behind finding the vertex is that we can plug in the line of symmetry in order to get the y value. So the line of symmetry itself represents the x value of the vertex, and then the result we get from plugging it in for x and solving for y tells us our y value of the vertex. So we'll start with standard form. We already found on the previous slide that the line of symmetry is x equals 1. And so I'm going to write the standard form and replace all the x's with a positive 1. Simplifying from there gives me a value of 50. So the x value of my vertex is 1, the y value of my vertex is 50. Now we'll take a look at vertex form. Again, if we plug in the value of 1 for x and simplify, then that leaves us with the number that's on the outside of the parentheses, which is 50. And so again, x value of the vertex is 1, y value of the vertex is 50. And then with factored form, same thing. I'm going to replace the x's with the line of symmetry, which is 1. And then I will simplify what I have there to get my result of positive 50. Now we'll take a look at writing a rule to match a given graph. In this case, I've got one example, but I've got all the different types of information that we've looked at previously in order to set up these rules. If you're given the x-intercepts, then all you need is another point, and you'll use factored form to write your rule. So first we'll identify the x-intercepts, and then set up the factored form that would match those x-intercepts. The a value is the missing piece of information that we need to be able to solve for, and to do that we need another point. In this case there's already one marked on the graph, 3 and 32. So I'm going to replace y with 3 and replace I'm going to replace y with 32 and replace x with 3. And then use the equation that I just wrote to solve for a. In this case, if you do the division for that fraction, you end up with a decimal that you would have to round. So I'm going to go ahead and leave my answer in fraction form and then just rewrite the final rule. Don't forget that you can check this answer by putting your rule into the calculator and then going to the table to make sure that the points that you used show up somewhere in the table. We can also write a rule for this graph in vertex form. If we're given the vertex, then that's the form that we would use to set up. And notice that in both cases, whether you use vertex form or factored form, you still need another point from the graph in order to solve for the a value. So we'll identify the vertex, which is 1 and 50. and we'll set up the vertex form that would match that value. Then we'll use that other point that's already identified, plug in 32 for y and 3 for x, and use the resulting equation to solve for a. Subtract 50 from both sides, squaring 2 gives you 4, and again we end up with a fraction in this case, and we'll go ahead and leave that in fraction form. So writing my final rule, would have my fraction in front, and then my vertex form that matches the vertex that we were given for the rest of the equation. Again, you can make sure to check your answer by putting that into the calculator and seeing that the points that you were looking for show up on the table. At this point, I hope that this helps. If you're still in need of extra practice, be sure to ask. If you're in need of some extra help, make sure you try and come into the KMAC or come in before or after school.